Welcome to our channel. Today we're diving into some of the most mind-blowing planetary phenomena in the universe. You know, the kind of stuff that makes you realize just how vast and strange the cosmos truly is. We're talking about toxic atmospheres that would melt your face off, metal rain that would make even the toughest robot cry for its mommy, and day-night cycles that last longer than entire civilizations. Get ready to have your mind blown as we explore the outer limits of what's possible in our universe. We'll be venturing to distant exoplanets, those alien worlds orbiting other stars, and we'll even take a closer look at some of the bizarre wonders right here in our own solar system. So buckle up, space cadets, this is going to be one wild ride through the cosmic landscape. Imagine a planet where the very air you breathe could kill you. And I'm not talking about some measly Earth-like pollution. I'm talking about atmospheres so toxic they'd make Venus look like a breath of fresh air. Think about it. On Earth, our atmosphere is mostly nitrogen and oxygen with a dash of other gases. It's what allows us to breathe, what gives us our blue skies, and what protects us from the harsh radiation of space. But on other planets, the atmospheric cocktail can be a recipe for disaster. Take, for example, a planet with an atmosphere dominated by carbon dioxide. Now we have some CO2 on Earth, and it's a greenhouse gas, meaning it traps heat. But on a planet with a super thick CO2 atmosphere, the greenhouse effect would be off the charts. The surface temperature could be hot enough to melt lead. Not exactly a hospitable environment for life as we know it, and that's just the tip of the toxic iceberg. Some planets have atmospheres choked with sulfuric acid, the kind of stuff that eats through metal. Others are shrouded in methane, which is flammable to say the least. And then there are the atmospheres with exotic chemicals we haven't even discovered yet. Now you might be thinking, well, what about robots? They don't need to breathe, and you're right. But even robots have their limits. Extreme heat can fry circuits, corrosive gases can eat through metal, and high pressures can crush even the toughest machines. So, yeah, exploring these toxic worlds is no walk in the park. It's going to take some serious engineering and a whole lot of ingenuity to build probes that can withstand these extreme conditions. But hey, that's what makes it fun, right? Okay folks, let's talk about rain. Here on Earth, we're used to the refreshing, life-giving kind, the kind that nourishes our plants, fills our rivers, and gives us those beautiful rainbows. But on some planets, rain takes on a whole new meaning. Imagine a world where the rain isn't just water but something far more exotic and dangerous. I'm talking about metal rain, people. Yes, you heard that right. Rain made of molten metal. Rain so heavy it would make a hurricane look like a gentle breeze. Imagine the sheer force and intensity of such a downpour. Now you might be wondering, how in the universe does metal rain even work? It sounds like something out of a sci-fi movie, right? Well, it all comes down to temperature and pressure. These two factors play a crucial role in the formation of metal rain. You see, on planets that are super hot, like hotter than the surface of some stars hot, metals like iron and nickel can exist in a gaseous state. It's hard to imagine, but these metals can actually vaporize. That's right, gaseous metal. Picture a world where the air is filled with metallic vapors. Now imagine an atmosphere where it's so hot that these metallic gases are just hanging out, chilling like it's no big deal. It's a completely different kind of weather system. But then, as you go higher in the atmosphere, things start to cool down a bit. The temperature gradient causes these gases to undergo a transformation. And when these metallic gases cool down, they condense, just like water vapor does on Earth. This condensation process is key to the formation of metal rain. But instead of forming fluffy white clouds, they form clouds of molten metal. Imagine clouds that are glowing with the heat of molten iron and nickel. And when these clouds get heavy enough, boom, metal rain. It's a phenomenon that's as terrifying as it is fascinating. It's a sight that would make even the most jaded astronomer jump for joy. The discovery of such an event would be groundbreaking. Imagine molten iron and nickel droplets, some as big as your fist, cascading from the sky. It's a spectacle that defies our earthly experiences. It would be a metalhead's dream come true. A concert of cosmic proportions with the universe itself putting on the show. Now, we haven't actually observed metal rain directly yet, but the theoretical models and simulations give us a pretty good idea of what to expect. But based on what we know about physics and the extreme conditions on some exoplanets, scientists believe it's not just possible, it's downright likely. The data we have supports this fascinating possibility. In fact, there's a planet called WASP-76b, where astronomers think they've found evidence of iron rain. This discovery has opened up new avenues of research. This planet is tidally locked to its star, meaning one side always faces the star, and the other side is in perpetual darkness. This unique condition creates extreme weather patterns. On the day side, temperatures soar to over 4,000 degrees Fahrenheit, hot enough to vaporize iron. The heat is so intense that it turns solid metal into vapor. And on the night side, it's much cooler, allowing the iron vapor to condense and rain down. This temperature contrast is what drives the metal rain cycle. Talk about a metal concert you don't want to miss. The universe truly has some spectacular shows in store for us. Chapter 3. Let's talk about time, or more specifically, the passage of time on other planets. Time, as we know it, is a fascinating concept, and it behaves very differently depending on where you are in the universe. Here on Earth, we take our 24-hour day for granted. It's a rhythm that dictates our lives from the moment we wake up to the time we go to sleep. But out there in the vast expanse of the cosmos, there are planets where a single day or night can last for centuries. These planets defy our understanding of time and challenge our imagination. Imagine that for a second. A world where the concept of a day is stretched beyond our comprehension. A day so long that entire civilizations could rise and fall before the sun sets. Think about the history that could unfold in such a span of time. So, how is this even possible? What causes these planets to have such extraordinarily long days and nights? Well, it all comes down to a fascinating phenomenon called tidal locking. This is a process that can dramatically alter a planet's rotation. You see, when a planet orbits a star, the star's gravity tugs on the planet, just like the moon's gravity tugs on Earth's oceans, causing tides. This gravitational interaction is a powerful force. Now, over vast stretches of time, this gravitational tug-of-war can actually slow down a planet's rotation. It's a gradual process, but its effects are profound. And if the planet gets close enough to its star, this slowing down can continue until the planet's rotation period matches its orbital period. This synchronization is a key aspect of tidal locking. In other words, the time it takes the planet to rotate once on its axis becomes equal to the time it takes to orbit the star once. This results in one hemisphere of the planet always facing the star. When this happens, the planet becomes tidally locked to its star, always showing the same face to its stellar companion, just like the moon always shows the same face to Earth. This creates a unique environment on the planet. Now, on one side of this tidally locked planet, it's perpetual day, with the sun blazing overhead for centuries on end. This side experiences constant sunlight and extreme heat, and on the other side, it's eternal night, a realm of perpetual darkness. This side is shrouded in darkness and extreme cold. Now you might think that a planet with a day-night cycle that lasts for centuries would be a pretty boring place. But think again. The dynamics of such a planet are anything but dull. The extreme temperature differences between the day side and the night side could create some seriously wild weather patterns. These patterns would be unlike anything we experience on Earth. We're talking hurricane-force winds, planet-wide storms, and maybe even some atmospheric phenomena we haven't even imagined yet. The interplay of heat and cold could lead to a dynamic and ever-changing environment. Chapter 4. Hold on to your hats, folks, because we're about to venture into the realm of pure speculation. This is where science meets imagination, and the possibilities are as vast as the universe itself. What if, and this is a big what if, there were planets out there with living clouds? Imagine clouds that aren't just passive formations of water vapor, but dynamic entities with a life of their own. Clouds that moved and changed shape like creatures, soaring through the atmosphere of some alien world. These clouds could be as diverse and complex as the ecosystems we find in our oceans or forests. Now I know what you're thinking. Neil, have you been hitting the cosmic bong a little too hard? But hear me out. This isn't just wild fantasy, it's a thought experiment grounded in the principles of astrobiology. Life, as we understand it, needs a few key ingredients: water, energy, and certain chemical elements. These are the building blocks of life as we know it, and they are surprisingly abundant in the universe. And guess what? Atmospheres are full of those things. They are dynamic, ever-changing environments that could potentially harbor life forms adapted to their unique conditions. Think about it. Clouds are basically just water vapor condensed around tiny particles in the air. These particles could serve as the foundation for life, much like the primordial soup on early Earth. And where there's water, there's the potential for life. This is a fundamental principle of astrobiology that drives our search for extraterrestrial life. Now, I'm not talking about little green men flying around in spaceships. I'm talking about life forms that are far more subtle and perhaps even more fascinating. I'm talking about microscopic life forms, maybe even single-celled organisms, that have evolved to thrive in the unique conditions of a planet's atmosphere. These organisms could be the pioneers of life in environments we can barely imagine. These hypothetical cloud creatures could feed off the energy from their star, just like plants do here on Earth. They could photosynthesize, converting light into energy to sustain themselves. They could use the chemicals in the atmosphere to build their bodies, just like we do. The atmosphere could provide all the nutrients they need to grow and reproduce, and they could even communicate with each other using electrical signals, just like some animals do here on Earth. Imagine a network of cloud-based life forms exchanging information and coordinating their activities. Now I know this is all very speculative, but speculation is the first step towards discovery. It's how we push the boundaries of what we know and explore the unknown. But the universe has a funny way of surprising us. Just when we think we've seen it all, we discover something that challenges our understanding of life and its possibilities. We've found life in some of the most extreme environments on Earth, from boiling hot springs to the frozen depths of the ocean. These discoveries remind us that life is incredibly adaptable and resilient. So, who's to say that life couldn't exist in the clouds of another planet? The conditions might be harsh, but life has a way of finding a foothold in the most unlikely places. Imagine a planet with a thick, swirling atmosphere constantly bombarded by energy from its star. This energy could drive the processes necessary for life to thrive. Now picture vast, interconnected networks of living clouds stretching across the entire planet. These clouds could form a complex, interdependent ecosystem. These clouds could be different colors depending on the chemicals they're absorbing. The diversity of their hues could be a visual representation of their chemical makeup. They could move and pulsate, reacting to changes in the atmosphere. Their movements could be a form of communication or a way to gather energy and nutrients. They could even communicate with each other, creating a planet-wide network of living organisms. This network could be as complex and intricate as any ecosystem on Earth, a testament to the boundless creativity of life. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content about the universe. We've explored some of the most mind-blowing planetary phenomena out there, from toxic atmospheres to living clouds, but remember, this is just the tip of the cosmic iceberg. There's still so much out there to discover, so many mysteries to unravel. So keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the universe. See you next time.